The process of a nuclear explosion is a powerful and complex phenomenon, one that begins with the meticulous assembly of a nuclear device, typically containing either uranium-235 or plutonium-239 as its fissile material. These materials are carefully arranged to create a supercritical mass, a configuration that allows a sustained nuclear chain reaction to occur. Once the bomb is detonated, conventional explosives first compress the fissile material into a smaller, denser form. This compression is crucial, as it brings the atomic nuclei close enough together to trigger a chain reaction. In an instant, neutrons are released, striking the nuclei of uranium or plutonium atoms, causing them to split. This is the process of nuclear fission. Each fission event releases more neutrons, which in turn cause additional fissions, leading to an exponentially growing chain reaction. The energy released in this fission process is staggering. Within a microsecond, the temperature at the bomb's core reaches tens of millions of degrees Celsius, comparable to the core of the Sun. This immense heat causes the surrounding material to vaporize instantly, creating a rapidly expanding fireball of incandescent gas. The light produced is so intense that it can be seen from hundreds of miles away, and the heat can cause severe burns and ignite fires even at great distances. As the fireball expands, it generates an extremely powerful shockwave. This shockwave travels outward at supersonic speeds, obliterating everything in its path. Buildings, trees, and anything else in the vicinity are flattened by the sheer force of this blast. The shockwave is followed by a powerful wind, moving at hundreds of miles per hour, which further compounds the destruction. The iconic mushroom cloud that forms after the detonation is a result of the intense heat causing the air to rise rapidly, pulling dust, debris, and radioactive particles into the atmosphere. This cloud can reach altitudes of tens of thousands of feet within minutes, carrying radioactive material high into the stratosphere. The fallout from this explosion is perhaps one of the most insidious consequences of a nuclear detonation. Radioactive particles are dispersed over a wide area, depending on wind patterns and other atmospheric conditions. This fallout can settle over thousands of square miles, contaminating the land, water, and air with radiation that remains hazardous for years, even decades. The immediate effects of a nuclear explosion are catastrophic, devastating blast damage, intense heat, and lethal radiation exposure. But the long-term impacts are equally concerning. Radiation can cause acute health effects such as radiation sickness, as well as long-term issues like cancer and genetic mutations that can affect future generations. The environment suffers as well, with radioactive contamination rendering large areas uninhabitable. Nuclear tests, conducted in remote areas to study the effects of these weapons, highlight the sheer destructive power of nuclear technology. These tests, while essential for understanding the mechanics and impacts of nuclear explosions, also serve as a stark reminder of the potential consequences if such weapons were ever used in conflict. The lasting environmental and health impacts of nuclear fallout emphasize the need for strict international controls and efforts toward nuclear disarmament. The goal is to ensure that the horrors of nuclear warfare remain in the realm of history, never to be repeated in the future.